Hello, everyone. Micronutrients is the topic of the day. This is Dr. Jenkins. Here we go. Excuse me. So, we have finished talking about all of the macronutrients. Remember, carbohydrates, fat, protein, and water. So, it makes sense that we now turn our attention to the micronutrients, which are the vitamins and minerals. Remember, micronutrients are considered micronutrients. Maybe, I feel like I'm using red a lot. I want to change it up a little bit. How about green? How's green going to look? Remember, micronutrients means that these are needed in smaller amounts in the diet. It's not that the micronutrients are necessarily smaller in size, although sometimes that's true. But the real reason the prefix is micro is because they're needed in smaller amounts through diet. Versus the macronutrients, which we needed in larger quantities through the diet. Let me remind you, these micronutrients, even though we don't need as many of them through our diet, they're just as important. They're vital. We need them. Okay, here's your outline. Let's just jump right in, folks. Okay, so I've already said that the micronutrients are needed in smaller amounts through diet, but they are no less important. And we need to get them through our diet because 99% of all the vitamins and minerals our body cannot produce on its own. You can see here we can synthesize some vitamin D on our own, but that's it. So we have to get them all through diet, almost all through diet. Overall, I like to consider vitamins and minerals a supporting cast. Even though they don't directly provide energy, like, say, carbohydrates and fat do, they are still vital, which means we absolutely need them in order to carry out our normal body functions. So in some ways, it's like the players on the bench. Think about the first couple players off the bench. You absolutely need them. They're not the star of the show, but they are part of the team, and it's only as a team that we can be successful. All right, so we're going to start with vitamins, then we'll talk about minerals. Okay, a couple things to point out here. As usual, I'm going to let you know exactly what you need to know. You need to know that vitamins are considered organic, and they're considered organic because they contain carbon. What we're going to find is this is not the case for most minerals. Most of our minerals do not contain carbon and therefore are not considered organic. What we're going to see in a minute, it is because of this carbon that vitamins tend to be more fragile, if I can spell. It is because of this carbon that vitamins tend to be more fragile than minerals. They tend to oxidize quicker. We need to handle them with more care, okay? The functions we're going to talk about individually. What are some unique things about their digestion and absorption? Vitamins do not need to be broken down. This is a unique thing because when we talked about carbs, fats, and proteins, they did need to be broken down or digested. But vitamins do not. So that does mean that we can absorb them more quickly. Okay, let's talk about that fragility. That fragility is due to the fact that vitamins are organic. They contain carbon. So as you know, if we sit an open apple out into the air, or an open banana out into the air, or an open avocado, or artichoke out into the air, it can turn brown here, right? And that's because it's oxidizing. And that's just the chemical reactions happening once it's exposed to oxygen. So it just means we need to handle it with more care. Let's see. I do want to point out this. We are able to absorb more vitamins in raw foods versus cooked. So oftentimes the cooking process actually removes our ability. It removes a number of total vitamins, and it lessens our ability to absorb the vitamins. Does this mean that we should be ingesting an all raw diet? Not necessarily. Plenty of cooked foods with vitamins are delicious. But it's not a bad idea to have some raw foods as well. Like an apple. Fantastic. Okay. In terms of structure, there are two categories of vitamins, the water-soluble and the fat-soluble. You can memorize these however you want. For me, when I learned about this, I was able to just memorize A, D, E, K, which meant that the remaining two, B and C, were water-soluble. A, D, E, K were fat-soluble. All right. So we're going to be comparing the water-soluble and the fat-soluble vitamins in a variety of things, in a variety of ways. Now, jump off the ledge. I can see you. Oh, no. I'm not going to ask you to know all of this, but you know me. I'm here to provide you with as much information as possible. Because these tables, it's good stuff, man, these tables. But as we go through, I will let you know exactly what parts of these you do need to know. But we have a nice summary table that we're going to refer back to. All right, we are going to start with our water-soluble vitamins, which are vitamins B and C. Water-soluble vitamins can be absorbed directly into the bloodstream. That's really what it's all about. Can be absorbed directly into the bloodstream. That's because they're water soluble, and the blood is mostly water. This is not going to be the case with the fat soluble. The fat soluble vitamins will not be able to be absorbed directly into the bloodstream. Let's see. What I want to point out about the water soluble is they are not, so we would like to know this, they're not stored in organs of the body. I think we'll leave it at that. So let me go back to this. So look, for our water soluble, I'm going to put these in green. For our water soluble vitamins, they can be absorbed directly into the blood. And they are not stored in large amounts in organs. So in other words, we can't have a storage of vitamin C in the liver for later. We tend to just keep in the bloodstream circulating a certain amount, but we cannot store them in organs for later. This bottom part is true, but I'm not going to have you know this. I think you have enough to know. But it is true that vitamins B and C we need in smaller amounts but more often versus the fat soluble, which we tend to not need as often in our diet. But I'm not going to ask you that on the test. Okay, so with the B vitamins, there's actually a whole category, and these are also included in the B vitamins, actually. So we have B1, B2, B3, B6, B12, folic acid, biotin, and pantothenic acid. They're all B vitamins. And then we have the vitamin C, which kind of stands alone. We are not going to break down each individual B vitamin just due to time constraints. And what I'm going to do is I'm going to provide you with a nice table that gives all the information for these different B vitamins. So if you ever had a question, you could just look it up. But I certainly don't think asking you to memorize all these very in-the-weeds specifics is a good use of your time. Okay, remember that when you do my end-of-semester evaluation. Haha. Okay, so instead, we're going to talk about the B vitamins together. So all of the B vitamins collectively share, for the most part, one common function. The B vitamins act as coenzymes. Now, we already know what enzymes are. Enzymes are these things that help speed up chemical reactions? Well, check it out. Sometimes, well, let's go with red this time. Oh, that's pink. I want red. All right. Sometimes the enzyme is the purple thing. Sometimes attached to the enzyme is a coenzyme. So here's the finished product. The enzyme is in purple. And then the coenzyme is this peach color. Coenzyme. So B vitamins tend to function as these coenzymes. And most specifically, they help with coenzymes that help the body to metabolize carbs, fat, and protein. So they assist coenzymes that help in metabolizing the macronutrients, which are carbs, fat, and protein. And to a much lesser extent, protein. So we don't need these B vitamin, let me rewind. 3, 2, 1. Okay. These B vitamins do not directly metabolize carbs, fats, and protein for energy, but they play an indirect role. Because when our body needs to metabolize carbs, fats, and proteins, they're going to need these enzymes with the coenzymes. And what are the coenzymes made out of? B vitamins. So for athletes who are going to be metabolizing a lot of these for energy, because they're burning more energy, the B vitamins are very important. All right. We didn't really talk about the specific steps, which are listed here, of metabolizing glucose into ATP. So that's why I'm trying to be pretty simple here. But this is the point that I wanted to make. Enzymes that break down, absorb, and metabolize, by the way. Let's add that. Metabolize for energy. Enzymes that break down, absorb, and metabolize carbs, fat, and proteins cannot work without the help of coenzymes. And these coenzymes are formed with B vitamins. Okay, cool. There's a picture of a dog here because when I talk about this in the more specifics, I liken the enzyme to the dog and the little backpack as the coenzyme, because one of the functions of a particular coenzyme is that it carries electrons, like almost putting in a little backpack and carrying the electrons along. All right. I got a little carried away with that one. Okay, vitamin C. Now listen, for all these vitamins and minerals, I told you already I'm not going to have you know all of them. We're starting here with the water-soluble vitamins B and C. We collectively grouped all the B vitamins together, and I asked that you know that all the B vitamins together help in the role of forming coenzymes, and that we need these coenzymes in order to metabolize carbs, fat, and protein for energy. Let's talk about vitamin C. I am not going to ask you to know all of these functions. I'm only going to pick out a couple. Okay. Vitamin C. One of its important roles is that it acts as an antioxidant, and I'm going to talk about that in the next couple of slides. I'm also going to point out that we need vitamin C to make collagen, which is a type of protein. And I know you're probably looking down here, it boosts the immune system. It does, indirectly. Vitamin C alone is not going to fight an illness, but it can boost the immune system indirectly. But I wanted to point out some other functions that you may not have been as familiar with. So it acts as an antioxidant, which I'm going to talk about in a minute. And vitamin C is needed to make this really important protein called collagen. And we use that an important protein, collagen, in our bones, in our skin, in a lot of places. Excuse me. The rest here is extra, but these are the two that I would like you to know. These antioxidants. When we talk a little bit later in the fat-soluble vitamins, vitamin E is also considered an antioxidant, but we're focusing on vitamin C right now. So vitamin C is an antioxidant. And an antioxidant, at the very top, as you can see, is a compound that, quote-unquote, neutralizes free radicals. Well, what on earth does that mean? Sounds like it's an advertisement for some beauty cream, doesn't it? Let's be a little bit, let's break it down into a way that's a little bit easier to understand. How I would break antioxidants down is that they help break down bad things. So when they say helps neutralize free radicals, what they're really saying is break down and get rid of. So these antioxidants help us to break down bad things. And it's just a certain type of bad thing called a free radical. So these free radicals are bad in excess. So we're always going to have some free radicals floating around. We have them naturally because they're a natural byproduct of metabolism for energy. And we can also get them from outside sources. Secondhand smoke, pollution, UV rays, I'll circle this one. So these free radicals, for example, tend to be a natural byproduct of any time we metabolize a macronutrient for energy. And if they build up, it could have negative effects on the body. So what an antioxidant does is it helps to break down these free radicals so they don't accumulate. Keeping it very simple here. You can see this little schematic. It's from a different textbook than your textbook, but it shows these free radicals as these little red things. Free radicals. They're byproducts of normal chemical reactions, but also can be obtained from secondhand stuff. And what the antioxidants do is they, quote-unquote, neutralize them. They help. You could look at it as break down, or you could look at it as these antioxidants attach to the free radicals and remove some of their negative contents. But either way, we're getting rid of the negative part of the free radical. See, here the free radicals are red, here they're not. So because of the antioxidants, we've helped to get rid of the bad part or break down the bad part of the free radical. Okay. More on this, huh? You hear a lot about this stuff. Athletes are going to have a slightly higher need. And this should make sense. Remember, one of the ways that we generate these free radicals is through the metabolism of carbs, fat, and protein for energy. So because athletes are expending more energy, they're doing more metabolism of carbs, fat, and proteins, we're going to release more free radicals. Do you need a supplement? Not necessarily. If you can get enough vitamin C through your diet, which shouldn't be that hard. Okay. All right, so as I said to you, I'm going to give you a lot of information, but you don't have to know all of these. What we talked about that I would like you to know is, as a whole, many of the B vitamins help to form coenzymes that are needed to metabolize carbs, fat, and proteins for energy. We talked about vitamin C being an antioxidant and helping in the formation of collagen. You can see on the right all of the yummy sources. I'm not going to ask you that, but it's there if you'd like, okay? I do want to point out a couple of things. We know that vitamin C is in citrus fruit, but did you know there's quite a bit of vitamin C in vegetables? And wait a minute, I see veggies up here. Huh. And I see veggies down here. So we're going to see a lot of these vitamins and minerals are found in vegetables and other things, fruit, meat. But this is one reason why it's so important to get those fruits and vegetables in your diet, ladies and gentlemen. But I'm not going to ask you to know any of the specifics. Here's more information for you. There's the daily needs, which I'm not going to ask you. There's what could happen if you had too much, which I'm not going to ask you. Sometimes there isn't really a toxic effect. But what I do want to point out is some of the potential deficiencies. And I'm only going to have you know this one. But see, if you know the function of the B vitamins, then you're already going to know what's going to happen if you have a deficiency. If our function is to help us form coenzymes that are needed to metabolize carb, fat, and proteins for energy, well, if I have a deficiency of the B vitamins, I'm not going to be able to metabolize as much nutrients for energy, and I may demonstrate weakness. See how that works? If you know the function, you can figure out what would happen if there is a deficiency. Imagine that. All the rest here is extra. Okay, let's switch gears to the fat-soluble vitamins. These are vitamins A, D, E, and K. Let's talk about these fat-soluble vitamins in more detail. Fat-soluble vitamins cannot be absorbed directly into the bloodstream. Oh, didn't mean to do that. And this is different. This is the primary difference between the water and fat-soluble vitamins. The water-soluble vitamins can be absorbed into the bloodstream. Let me change that, directly into bloodstream. But because these are fat-soluble, they cannot be absorbed directly into bloodstream. They have to first be absorbed into these lymphatic vessels, which then the lymphatic vessels will deliver these vitamins to the blood. But that's all you need to know. Fat-soluble vitamins cannot be absorbed directly into the bloodstream. And unlike the water-soluble, the fat-soluble vitamins can be stored in organs. All right. So here we already talked about the water-soluble vitamins, and we talked about how they are absorbed and their storage. Let's switch to the fat-soluble vitamins. We know that they cannot be directly absorbed into the bloodstream, and they can be stored. Just as an aside, if you look at the bottom, I did say that we tend to need more frequent doses of getting the water-soluble vitamins in our food, small amounts often, versus the fat-soluble. We don't need to ingest quite as often, but I'm not going to ask you that. All right, let's pick some things for you to know. All right, despite what the stars that are on here, I'm going to change my mind and pick the ones that are most specific to us as athletes, because this is, after all, a sports nutrition class. Vitamin D. Vitamin D is needed for bone health. And as an aside, vitamin D also helps with our calcium absorption. Vitamin E has similar functions as vitamin C, which is as an antioxidant. And I actually do think it's important that we know vitamin K. And vitamin K functions to help us with blood clotting. So if you have some sort of cut or injury and there are broken blood vessels and there's bleeding, whether you can see it on the surface of your skin or not, we really require vitamin K for our body to carry out its normal blood clotting process. How I remember vitamin K and blood clotting is because even though it's not the same letter, K with the C for blood clotting, they have a similar sound. Blood clotting. K for clotting. That's how I remember it. You can read about the sources, but I'm not going to ask you any of those. It's just a nice reference for you. You can read about the daily needs, the effects of the excess, but I'm not going to ask you those. But I will point out these two effects of a deficiency. But it's the same thing as it went for with the water-soluble vitamins that I said before. If you know what the normal function of the vitamin is, you can figure out what's going to happen if you don't have enough of it. Vitamin D helps to maintain strong bones. So if I don't have enough vitamin D, my bones might be weak. Women, particularly older women, or women who are in sports that require them to be very lean, they could be at a real risk for a vitamin D deficiency. Vitamin K helps with blood clotting. So if I don't have enough vitamin K, I may not be able to control my bleeding, which would be very bad. Okay, we're going to finish off vitamins, then we'll stop this video, and then we'll pick up the next video with vitamins. Let's talk overall. Overall observations. If we don't have enough of the B vitamins, athletes can feel fatigued. Other things listed there are true, but I'm not going to ask you about them specifically. I think a lot of athletes, it's pretty easy to focus on carbs, fat, and protein, but you may not be focusing on as much of these vitamins and minerals. And folks are just as important. Think about particularly with recovery after a heavy workout, or God forbid you have an injury. Then we're asking our body to work overtime to repair the muscles or repair whatever tissues were damaged in the injury. Vitamins and minerals are an important part to good recovery from a hard workout, but also a good recovery from an injury. Okay, other observations. With exercise, we need slightly more vitamins, increased requirements. It may not be a significant need, but we do need more as athletes, particularly the B vitamins. So athletes need to be paying attention to this. We do lose some vitamins through our sweat. Not a large amount, but it's some that non-athletes aren't going to experience. Okay? Recommended intakes. Okay. So if you were to look at the recommended dietary allowances for adults, that may not be enough for athletes. Because remember, athletes need slightly more. Particularly, these are the vitamins that athletes would need more of. I mean, all of them across the board. But if I was going to pick 3 vitamins that I would make sure an athlete was getting enough of, I would pick B, C, and D. But, as I've been saying over and over and over again, exclamation point, exclamation point, exclamation point. Even though athletes usually have a slightly higher need than a non-athlete, most of their needs can fairly easily be met through a well-balanced and particularly higher carbohydrate diet that includes fruits and vegetables. All right. I give you the information on the specific upper intake levels, but you do not need to know this. I just like giving you information. A lot of this is a good reference for you to have. There are athletes that are more at risk for a vitamin deficiency than others, and this is not going to surprise you. Just like we talked about with our macronutrient deficiencies, it's the same thing with the micronutrients. So weight-specific sports, where you need to be a certain weight or look a certain way, because they're more likely to be restricting their overall caloric intake, they're more likely to be deficient in everything, including vitamins and minerals. I mentioned females before, but this is particularly true with bone health. Women don't have as much testosterone, and they have more estrogen, and just the way that women are put together can make them a little bit more at risk. When we get to the minerals, we'll talk about female athletes being more at risk of an iron deficiency because of their monthly menses or period. The rest here, it's true, but won't be on the test. But things to think about. Some people are naturally a picky eater, and they may get into a routine of what they like. And that's fine, but if you are really limiting your food intake and having the same thing or similar things day in, day out, you might find yourself at risk for deficiency. So it's always good to mix things up and have a variety of foods when you can. Okay, this is the end of video 1. I will see you for part 2.